Hi guys, and welcome to another Visual C# tutorial. I'm Josef Botnar. In this video tutorial, I'm going to continue the series of calculator project tutorials. I have done two tutorials regard to calculator project. In one of them, I have done the design. As you can see, it is about this design of this calculator. So let's release it. And in another tutorial, I have done the code behind these numbers, behind these buttons which contains the numbers. In this video tutorial, the goal is to create the code behind the operations button. I mean these buttons, division, multiplication, addition, subtraction, and the code for the result button. I mean this button which contains this equal sign. So as you can see, I have done the code for the buttons. When you press one number, that number will appear here in this label, and also the number will be added to other numbers which appeared here in this label. But also I need these numbers to go away after I press one of these operations, for example division. And if I press 9, I don't want 9 to be added to the value which was previous. I want the number which was previous to gone away, and to be left just the number what I type last. Also I need to do a few changes here inside the code. For example, I don't need this method. Just I noticed it was left here from the previous tutorials, because I have done this event which works for all of these buttons for these numbers, and for this button left this method which is useless. So let's remove it. Yeah. Okay. So how I can get the sign of these operations? Actually, I need to get the signs which appear on these buttons. If I go here in properties, yeah, you can see here the text properties was set to this value, which is a sign for division, and the same the things are with others buttons for operation. For example, for multiplication, we've got this sign. So I need to get all these signs. Yeah. To do so, I have to do the same things what I have done for the number buttons. Yeah. So I select this button. Yeah. Double click on it. This will take me inside this method, which Visual Studio gave a name automatically, but I can change this name. I go here in properties. Yeah, let's select again this button, select the events, and go here where is this click event, and let's change it with a more suggestive name, like calculation. Yeah. Enter, and this will take you inside the method, and as you can see, the name of the method was changed automatically. So to get the operation size, I need a class button to create a object button which will take over the value of this sender object, which is a parameter of this method, calculation underscore click. Yeah. To do so, I need to do a cast using this class button, and after the object sender semicolon. Also, I need a string to get the value of this object button. Actually, this object button now can access all the properties of these buttons. And which properties I need? I need a text property, actually. Yeah. Because as I told you, this property text is set to these signs, these which are a value actually, which are a string actually. Yeah, which I need all these signs. Yeah, which are set to this property text. All right. So to do so, I go here, and I'm going to declare a string variable, and I'm going to name it calculation. Yeah, calculation. I'm going to assign it with these double quotes, which actually is null, is nothing to this string, and a double variable, name it a number, which will be assigned by 0. I need this variable to get the result of this label, to get the value held by this label. Yeah, that's why I need this double variable. Now I go back in my method, in my calculation underscore click method. Yeah, and here I'm going to use this string calculation to get, as I told you, the value held by this button, yeah, which are the signs of these buttons, which represent the operation, division, multiplication, addition, and subtraction. Yeah. All right. So calculation will be assigned by button object, and as I told you, this button now can get access for all the properties of those buttons for operations. Also, I'm going to use this number double variable to get the value of this label. Yeah, to do so, I have to do a double parse conversion. To do so, I have to do a double parse conversion. To check how this code works, a good method is to create a breakpoint. We click on this side of Visual Studio, and this red spot will appear. And now release your calculator or your app. Press, for example, the division operation button. Yeah. And now, if you go over sender object with a cursor, you will see this sender contains this sign for the division. Yeah. So that's why I needed to create this object to take over the value of this object sender, which contains, as you can see, all the signs for operations, in this case the division, but it works the same for all other operations. Yeah. Now the button object is not assigned yet, yeah, because I have to press this step over icon, and as you can see now, this button object was signed by this division operation, and so on. And if I step over again, now the calculation string took over the division operation sign, as you can see. Yeah, and so on. I stop now the application. In this way, you can check your code, how your code works, if your code works properly or not. This is a very good way to code. I used to make breakpoints a lot. I used in my code breakpoints a lot. In this way, I can check my code, how it works. Okay, so let's go ahead. Let's release first the calculator. How this works in this moment. I press a number, is appended here, appear here in this label. Yeah, I press another number, is appended to the previous number, and so on. After I press, for example, one of these operations, for example, the division operation, and I press another number, as you can see, the previous number doesn't disappear. So this is not good. So this means the calculator doesn't work properly in this moment. What I have to do? One of the methods is to create a logical Boolean variable like this one. I'm going to name it OP. and I'm going to assign it with true. Yeah, okay. And here, go inside this event, which is for numbers. Yeah, and add here in this if structure this operator for OR. Yeah, parentheses, and inside the parentheses this OP logical operator, or sorry, this logical variable, or this flag variable. Actually, this variable, this logical variable OP works like a flag. Yeah. Okay, and I have to add here also this OP flag variable to be false, and here I want this OP variable to be true. Yeah. So let's see how this works now. Let's release again my calculator. Let's press 7. Let's press this multiplication operator button. 8. No, it doesn't work yet. Yeah. Let's see again. 7. This. Yeah, it works. It works now. Yeah. I press this one. It disappears. Yeah. I press this one. It doesn't disappear. Why? If I press this one, it works just for the division, as you can see, but it doesn't work for another operation buttons. Okay, let's see why. The problem is because I haven't copied and used this event for all of these buttons, for all of these operations buttons. Yeah, that is the problem. So I have to go here. I have to copy this event. I go to design and select the next one. Go to event, and you have to copy to paste it here inside this click event, all this event calculation underscore click. Yeah, the next one for addition. You have to do the same thing. Yeah. Okay. Okay. Let's see now. Now it should work at this moment. Yeah. Let's release again this up. 7 multiplication button 8. Yeah, it works. Division 9. Addition 56. Subtraction. Yeah. Now it works. So when I press a number and after I press the operation button, that number will disappear, and I can type another number there. Now it works. Okay, so let's go forward, and to make the code behind this result button, double click on it. I'm going to use the switch structure, and inside the parentheses the calculation string to get a sign of these operations. Yeah, curly brackets. The first case is plus, and here I'm going to use this LBL result, which is the label with this property text. Again, the number which is this double variable. Yeah, plus I can use again this statement here. Yeah, and I have to convert all this result to string. Yeah, because all the value inside these controls are string. Yeah, and because these two, the number which is holding the value of typed inside this label, is a double variable, as you can see here, and again I take over the result shown in this label using this LBR result object, yeah, which is the name for this label, and the value held by this label is convert to double, yeah. And finally I have all the result I have to convert to string, yeah. Break. Now I'm gonna to copy this statement and paste it 3 times, I think, yeah. Here minus, let's see what is the sign. This is the sign for multiplication, yeah. And here division, here you go. I don't need this parenthesis here actually, so this is extra, that's why I've got here this error. Alright, and the last one is default and break again. Also I have to assign again this OP variable, flag variable to true. Okay, alright, so let's see how this works. Okay, let's release again this calculator. Okay, so 78 plus 6, yeah, the result is 84. So let's check this with Windows 10 calculator, yeah. So let's do again 58 plus 6, the result is 64. So 58 plus 6, the result is 64. As you can see, my calculator works correct. Let's multiply this with 9. Yeah, let's multiply with 9. Oops, something went wrong, I don't know what. Let's do it again. I think I pressed another number. 78 or 9, yeah, 78 or 9, okay. Okay, 78 or 9. Something is wrong here with my calculator. Let's see what. Let's go back. Ah, yeah, I know. Yeah, this is the problem because I haven't changed the signs. And as it is now, actually, for the rest of the operations, this works like a concatenation, not like a operation, yeah. So I should change here with minus, here with multiplication, and here with division. Let's see now again. Alright, okay, let's get the Windows 10 calculator. Good. Alright, good. 8 or 9, 72, 8 or 9, 72, plus 258, plus 258, the same result, divided by 9, the same result. It works the same. Now my calculator works very good, no problem, yeah. If I press C, I get a 0, exactly like here. If I press C, actually this button remove all, yeah. It's nothing in here now. That is the difference between my calculator and this calculator from Windows 10, yeah. If I press here C, you will get the 0. Instead of this, in my calculator, the C button will remove all, so we'll clean this label. Okay, so if let's see how the decimal point works. If I press 1.2 and I press again the point, as you can see here in this calculator, Windows 10 calculator, the point is not added. But let's see how it works for mine. 1. Yeah, you see, if I press this decimal point, appears how many times I pressed this button, which is not good. So this decimal pointer button doesn't work properly for my calculator. I should do a change here. What I can do? One method, it could be to use a if structure in this way inside this event for numbers for these buttons, yeah. Include this decimal point number button, sorry. So I go here and I write this. Let's make this comment sign, yeah, to understand easier my code. I like to separate like code like that with these comment signs. Okay, so I'm gonna use this if conditional structure in the button object with this text property. If this is equal with decimal point, yeah, I'm going to fool the compiler. The compiler is doing what you are saying to it, yeah, so you can fool it. This is a method to build logical your code. So how I'm going to fool the compiler? I'm going to write again this if statement. I'm going to use this exclamation operator, which is a negation in programming, yeah. LBL result text, which are saying if the label contains the decimal point, actually if this label doesn't contain the decimal point, yeah, which as you can see is the opposite of this test of this condition, I'm going to write the same statement, which is not important at all because my goal is to fool the compiler, yeah, because if I press this button which contains the decimal point, yeah, that means this condition will be fulfilled. The compiler will come inside this if structure, but when the cursor will get here to the next if conditional structure, it will meet this condition, which is the opposite, yeah, which is saying if the label, I mean this one, doesn't contain the decimal point, yeah, so because that the cursor, the compiler will skip this, and actually here I have to cut this and paste it in here, and I have to write here else. We'll skip this if conditional structure to the end of this method, and in this way you will avoid to add more decimal point, yeah. You can check your code using as I did with breakpoints. You use a lot of breakpoints to check your code. This is a very good method, yeah. Now let's release again this up, and let's see if this method, what I have done here, works. So 7 point, yeah, you see I can't add more decimal points, so it works, yeah. So it's a good method, yeah. Plus 5 point, so I press very many times, but I can't add more decimal points, yeah. So in this way this code will stop you to add more points, decimal points than 1, yeah. But really I don't like to use the code like that. I'm going to comment out this code, and I'm going to use a flag Boolean variable, which I like more, like bool. Let's name it is decimal, yeah, and I'm going to assign it to initialize it with true, yeah. And here I'm going to use this if structure in this way. So I'm going to remove this. I'm going to write here is decimal, yeah, and inside here I'm going to, if the compiler will get inside this if structure, I'm going to the is decimal variable will be assigned with a false value on this line 45, as you can see. Also here I should assign this is decimal to true, yeah, and here again with true. Okay, let's see how this works now. Let's start my calculator. Let's release at the same time the Windows 10 calculator, and let's see how this works. Let's see if my calculator works properly. So 7.8 plus 5 point. Let's see if I can add more decimal points. I can't, you see. So the code works. 13. Okay, let's do another check. 7.5 plus 6.5. Yes, 14. 7.5 plus 6.5. Yeah, 14. Yeah. Okay. 5.8 plus 2.5. 5.8 plus 2.5. Yeah, I get the same number, so it works very well. Now this calculator, 78 plus 25.14, yeah, we'll multiply by 96, divided by 63, and so on. 78.2, 78.2, multiply by 96.2, multiply by 96.2, yeah, the same result, divided by 25.6, divided by 25.6, yeah, the same result. So now I checked my calculator was perfect. What I haven't done compared with this calculator, as you can see, if I press here the plus, the result of this label appear here, up here, yeah, plus 25, for example, yeah, the result appears here, yeah. I haven't done that label which display the numbers up here, yeah. So but even that my calculator works very good, no problem. So I leave you to do that the code for that if you want to in your calculator the result of this label to appear up here. I leave you to do that, yeah. So you can improve this calculator. Obviously you can do a lot of things, so I leave you to do the improvement what you want to do for this app. So I get to the end of this tutorial. So my calculator works. So I have done the design, I have done the code behind these numbers, I have done the code behind the operations buttons, and behind this result button. What it's left to do in the next video tutorial is to publish this calculator app. So see you next time. Thank you for watching this video tutorial, and I'm waiting for you to watch my other video tutorials. See you next time. Bye bye.